All right. First, we're going to talk about chapter 3 real quick and then just get the notes over with. Chapter 3 is about scatterplots. The entire chapter is about scatterplots. The whole chapter, scatterplots. The one thing about this chapter that people don't like is the sentences, the interpretation sentences. There's a lot of them. Your note card is not going to be math. It's going to be sentences for chapter 3, just so you know. I already know. Can you, what is what? You can. Well, you'll have to put their names on the board. Okay. Anyway, there are 3 things we're going to do. We're going to identify the explanatory and response variable on a scatter plot. Just spoiler alert, explanatory has an X in it, so that means it's the X variable. Nice. Okay, we're going to not graph scatter plots because if you guys can't graph coordinates, I'm pretty sure you can do that on your own. And then we're going to describe scatter plots using dots. Dots is just like socks, but for scatter plots. Homework, which is not due until Friday, is 1 through 11, odd 29 to 31. And it says, sitting in statistics class, keep hearing Instagram instead of histogram. She's very upset about it. I'm gonna stop showing you guys these jokes. I really liked that one. All right, here we go. Let's get this over with so you have time to do whatever it is you do, which is probably just talk over me. That's what we seem to do. Okay. Explanatory variable. Explanatory variable is the X. It helps to predict or explain the response variable. Mostly comes first means that, like, chronologically speaking, the X usually happens before the Y. So not all the time, but most of the time, like just in time, the X will occur first and then the Y will come off of that. Okay, so this is how I remember explanatory variable is X because they both have an X in there. Excellent. Response variable is the Y. The response variable is the outcome of what you're trying to study. It usually happens after. Okay, however, hopefully you left this giant gap. However, sometimes there's not a clear explanatory and response. Sometimes it's just 2 variables being measured against each other, but one didn't really predict the other, one didn't cause the other. one was not before the other. Will it be okay to move it right here? Okay. All righty. So identify the explanatory and response. Okay, so diamonds. Does the weight determine the price, or does the price determine the weight? Weight determines the price. Weight usually comes first, and then the price is determined off of that. So the explanatory is the weight, which is spelled like this kind of carrots. Okay, why are we doing this? Why are we deciding explanatory and response variables? Because you're going to set up axes. And the explanatory variable is going to go on the X, and the response is going to go on the Y when you graph your scatter plot. Okay, fun, interesting example. The SAT math score and the SAT reading score for a sample of students. Does the math score determine the reading score, or does the reading score determine the math score? Neither. Right. They don't really, one doesn't determine another one doesn't cause another one. You could actually argue that they're not correlated at all. No clear. Okay, let's just start with this part that says scatter plot so that you don't have to switch. Just do write the word scatter plot with a couple of bullet points. Okay, what is a scatter plot? Have you ever graphed a coordinate that was like dog, comma, 4? No, it have to be quantitative. It would have to be like 1, 4, right? Can't be categorical. You can't have words in your coordinates. I don't know, some kind of battleship thing, maybe. No, I don't know. Okay, I'm not gonna complicate this. All right. Now I have some tips for you. Okay, first tip, always scale your axes evenly, but you don't have to start at 0. If you guys remember, I don't know if you remember like middle school, you'd have like this sort of deal, and then there'd be like a thing. That's saying that there's a bunch of stuff, and then you could start it at like 21 or 250 or anything you want, but you don't have to start your axes at 0. You have to be careful with your math, but not required to start at 0 on either axis. However, always label your axes. Part of the scoring guidelines for the FRQs for these are just to check for the labels, literally. I have a question. Have I taught you anything that you didn't already know yet today? I think, yeah, but that's fine. Nothing wrong with that. I told you guys it was going to be easy and short. But would you believe that this is the end right here? By the way, Mr. Talbot really got into me for the second chapter here. I made an entire little Google slides for you for no notes on one day. I took out the entire set of notes and made a Google slides instead. And then I printed the Google slides for you. I know. He tells me that I need to be more efficient, but I think he means lazy. Yeah, efficient. Yeah. All right. Last little bit. And then I guess I lied. I guess you will have time to work on your note card. Okay. So direction, there's 3 options: positive, negative, and no association. Okay, underneath here in this little spot, we're going to draw little pictures of what these look like as far as the scatter plot goes. So direction, outliers, form, and strength is DOFs. You only use DOFs for scatter plots. SOCs is everything else. Let me say that one more time. You only use DOFs for scatter plots. SOCs is for everything else. So after you learn this, that's it really for describing all the graphs. So positive scatter plots go upward like this. Negative scatter plots go downward like that. And then no association, that's what I like to affectionately call baby spaghetti. Have you ever seen a baby eat spaghetti? They like throw it everywhere. So if your dots look like they're just thrown everywhere, that's no association. Any questions about the direction? Uphill dots, downhill dots, or baby spaghetti? Good? Okay, outliers. You're going to love this. There's no mathematical process to determine an outlier on a scatter plot. You just have to say it's possible. There's no 1.5 times IQR business because there's two variables in these. So you're just eyeballing it. Okay, form. There are two different forms. Linear and nonlinear. Linear looks like that. The dots are going in a straight line. Nonlinear looks like this, where there's a curve. It doesn't have to be a downward curve. It could be any kind of curve. Okay, and then there are three strengths. Weak, moderate, strong. Weak, they're kind of spread out, but you can kind of still see that they're going up. Moderate, they're going up. Strong is like not perfectly linear, but like pretty darn good. Okay, now we have a lot of people who actually prefer math in here as opposed to stats, and that's fine. Later in the chapter, I'm going to give you numbers to associate with weak, moderate, or strong, so you don't have to just guess. You're going to have an actual statistic that you can refer to. Maybe moderate or strong. That's it. That's really all I have for you today. It's the best lesson ever. You guys have a whole half an hour. You could study, do your homework. You could poke each other or steal each other's pencils.